Hello, everyone. Can I just get a yes if you can hear me in the chat? Okay, awesome. So I'm really excited to introduce our next speaker. Her name is Andra Keay. She is the Managing Director of Silicon Valley Robotics, the nonprofit industry group supporting innovation and commercialization of robotics technologies. She's here to talk about how robots are the canary in the AI coal mine and how the risk of autonomous systems involves more than physical safety.
Thank you so much, I saw here. I'm really looking forward to talking today. I'm just typing a link into the chat because I realize it's not in the presentation. And I've just come from a Women in Robotics meeting. If you're in computer science and you're still studying, I know there are a few affinity organizations for, Society of Women Engineers or Black in AI. We have got an affinity group for women in robotics. And if you identify as a woman and would like to join, then you can do that by going to womeninrobotics.org. I personally, through experience, I know how important it is that we have supportive affinity groups for people who are underrepresented in any career, really. But computer science has been a career that has been. There were probably more women in computer science in the 40s and 50s, really, or certainly proportionately speaking, than there are today. And so we have to address that. As it stands, women are more likely to do neuroscience than they are to do computer science. And that's sometimes the elephant in the room for our discussions. One of the things that I personally believe is that if we can provide more support as women leave university and move into the professional fields, that could help. But sometimes it's also really providing awareness of the problems that anybody from an underrepresented group faces. We like to think that things are meritocracies, but they certainly aren't when you really dig deeper, which is kind of the topic of the talk. And I'll just grapple with switching over to screen sharing. And starting my presentation. Why robots are the canary in the AI coal mine. And in fact, I thought that I was the only person to really be presenting this concept. But it turns out I did a little bit of looking around for some other references and images yesterday, and I discovered that Andra Keay, who is the CEO of the Allen Institute for AI and a computer scientist, actually wrote about robot canaries in the coal mines of AI at the start of 2020. And I thought, well, it's kind of interesting. I'm going to dive in. I'm going to have a closer look at what he considered to be the issues. And what Andra Keay was talking about primarily, and this is in the MIT Technology Review, was about how we can construct certain benchmarks that will indicate if AI is becoming a danger to society, really. But the definition of a danger to society is based around the idea that we're going to need something a little bit closer to general intelligence, artificial general intelligence, or something other than the narrow AI that we have at the moment. So he suggested that these three benchmarks would act as canaries in the AI coal mine. And it's the automatic formulation of learning problems, human level or better self-driving vehicles. So he sees autonomous systems as being one of the canaries in the coal mine. And the other one is AI doctors, as opposed to AI that interprets images or does a very, very narrow task. Now, that's very different to the way that I view robots as being the canary in the AI coal mine. In fact, I think that predicting problems of AI is the inverse of predicting problems of technology in the real world. And problems of technology in the real world is what I'm talking about when I see robots as the canary in the AI coal mine. And robots are a fantastic avatar or canary because they're highly visible, making life-critical decisions in real time, and they have to interpret the unpredictable physical world and human interaction. So these are all very difficult things for our current level of intelligence. And because robots are embedded in the physical world, they both have to do more complex tasks, and the tasks that they do are more critical. So this is the starting point for saying that robots are the ideal canary in the AI coal mine. But robots are also a scapegoat for exactly the same reasons. They're highly visible. The decisions that are made by an autonomous system could be quite critical. And it's a very complex role that they're having to play, which they usually do not do terribly well. In fact, the majority of robots in the world today are very simple devices. And the level of AI is in things like image interpretation, which can lead to real-time navigation. But why are robots the ideal scapegoat? It's because we as humans utilize our unconscious thinking systems the majority of the time, and we pattern match and we anthropomorphize. So when presented with something like a plate of saucepan of frying eggs, it's quite easy for us to see a face in there. And that means that we are highly susceptible to Moravec's paradox, where it is surprisingly difficult to create robots or AI that can do things that we consider to be humanly simple, whereas we praise robots and AI that do things that humans find difficult. And it gives us a very skewed sense of the intelligence level of robots and AI. And that means that if a robot can play a difficult game like Go or chess, something that humans find is difficult, then we think that it's smart. Whereas most AI is incapable of telling the difference between a cat and a dog. And this is something that human toddlers have managed to understand, those conceptual categories really well by the time they're a couple of years old. And the other tasks that Moravec said form his paradox are tasks that involve the sensory motor perception systems. And these are things that humans do unconsciously most of the time. But we haven't really developed AI or robotics that can perform those tasks. Now, one of the biggest misconceptions that we have about robots is that they're going to take our jobs. And if we start by thinking about Moravec's paradox, we'll realize that there are a lot of things that go into doing human-level jobs that we're probably not considering. For example, the ability to open doors is something that robots do terribly poorly. Yet we have this highly cited study by Frey and Osborne, two Oxford economists, who used machine learning to predict that 47% of all US jobs would be taken by robots in the next 20 years. Now, when I was young, there was a saying in computer science that was garbage in, garbage out. And just because they used machine learning and they used the US Department of Labor statistics to come up with this output, it still doesn't mean that it's not garbage in and garbage out. For example, they find in their study a 98% likelihood that fashion models will be replaced by robots. It was one of the most widely, that was a 98% level. Another job that was at the 98% likely to be replaced by robots level was chefs and cooks. Now we know that that is not going to happen. But most people don't dive in that deeply and read the appendix for the paper. This paper has been cited thousands of times, and it's informed policy and discussion at so many levels. Recently, some people are calling this paper out and saying, well, I don't think it's really that correct. One of the things that I have found occurs within these discussions is that there is a great amount of confusion and collapsing of the categories of computerization, automation, algorithms, machine learning, the internet, and robotics. And the fact that we have conversational agents called bots, or that we have computer automation called robotics process automation, doesn't help with the confusion, shall we say. Whereas really, if we look more deeply into what are the economic problems that people are concerned about that they're blaming robots for, then we'll find that the giant problems for people are computerization, globalization, and both of those leading to the gig economy. These are trends that have been developing for 40, 50 years and have really just reached a kind of saturation point now. This is not about robots taking jobs. It's not even about automation taking jobs so much. It's a little bit more, as Mark Andreessen said in 2011, software is going to eat the world. And indeed, Andrew Ng followed that up in 2017 by saying AI is the new electricity. But one of the problems with these statements is that the productivity statistics, and this is called Sokol's paradox, is that we have seen the impact of software everywhere in the world, except in productivity statistics. So if software is taking over the world, where else will we see the impacts? And why is productivity so slow to be affected by this? Now, a more optimistic study of this I've found more recently is McKinsey and Company. And they look at these eras and they say, okay, we saw huge productivity gains with the steam engine, with the railroads. We saw huge productivity gains with the tractor. And that was one of the biggest boosts of the 20th century. It was right at the start of that was the tractor and then the car. So we're seeing these physical technologies able to create great change. Now, McKinsey actually have come up with a fairly significant productivity statistic for software, but I believe that didn't really transition into an impact until in the 21st century, more as Andreessen is talking about, as software is starting to connect the dots. And it's really the combination of internet, ubiquitous connectivity, and computation software that has created the gig economy, for example. We had globalization before that, but now we're decomposing human tasks and we're distributing them to the cheapest possible places. Now, I call this one optimistic because they talk about an early productivity growth from robots. The timing of that, I think, is a little bit weird because we saw an early productivity growth from robots back in the 1970s. That was when the significant growth was, and 50% of all robots in what I call the Robotics 1.0 industry are still used in the automotive industry, with maybe a quarter that are used in the electronics assembling industries. But McKinsey looks ahead and it predicts a much larger increase in productivity as software becomes physical and is deployed in autonomous systems. Now, I do agree with them, but we're also predicting. This is not really based on evidence so far, but I do see it as a necessary thing that we have to look at. And the reason that we have to look at how do we increase our global productivity is because we are definitely facing an aging population problem. And indeed, the golden eras of employment in society in the 1950s, late 40s and 50s, post-World War II, you had approximately 5 working people supporting each retired person, so 5-to-1 ratio. What we're looking at within 10 years is a drop down to 2 working people for 1 retired person. And potentially, if things continue to, if we expand duration of life further, then by 2040, 2050, we can be looking at 1 person of working age for 1 person of retirement age. And slowly we're increasing retirement age as a way of dealing with it. It used to be 65, it's now 67 or 68 in most countries. And that trend is probably going to continue. We're going to expect people to work longer. I hope that what we can start to do is expect people to work smarter through the use of robots and automation. One other thing, and maybe this is where productivity is going, because we're not seeing it in terms of middle class income, or indeed the ability to improve family incomes at any level, unless you're in the top 1%. And the income inequality of the latter half of the 20th century and the start of the 21st century is greater than at any other time, except possibly when we're talking about pre-Roman Empire, the ages of empires. And even then, I've seen some modeling that says that it's worse now. And that's really scary. One of the other things, and I talked about this in terms of the impact of the internet and computerization on the workforce, it isn't replacing people with robots. It's about turning people into robots. We're continuing to decompose jobs into tasks. And tasks might be able to be done with automation or robots, but we're actually making people do tasks rather than jobs. And so I don't believe the problem is robots. The problem is, how do we rebalance this gig economy where artificial intelligence is being used by rich corporations to shave fractions of cents off their profit margin rather than for the good of society? So just to reiterate that, we are treating people like robots more than we're actually replacing people with robots. So the robot is a scapegoat for what we have been doing with computer science, really. And this has been a trend that started with Taylorism in the early 20th century to improve profit margins. And ultimately, we have to say this is a capitalist problem. And I think it would be great to see a deeper dive into economics alongside with any technologically based studying, because we potentially have the opportunity to fix. There's been talk back in the 80s, it was feminist economics. In the 90s, it was called triple bottom line accounting. And today it's called stakeholder capitalism as opposed to capitalism. There's also the movement towards free money, to recognize that we are potentially living in a period of abundance where things like a universal basic income should be quite possible. We should be using our ability to compute to be solving problems like that. And I have seen some groups of universities. In fact, I'm a visiting scholar with the Citrus group at the Universities of California. And this group was formed for information technology research in the interests of society. And robotics is part of that, but also so is health technologies, sustainable energy technologies, and the policies that go along with these things. What I like about being part of this group is that it's not simply looking at what are the technological problems and challenges that we can solve with research, or indeed what are the things that we can commercialize, but it's saying what are the things that we can do that are good for society. And I framed this talk to really pose this question: how do we consider not just the growth of AI, automation, and robotics, but the growth of technologies that have a positive impact on the world? For all of that, you'll have seen a huge increase in the amount of discussion around ethics for artificial intelligence and autonomous systems. But talking about it doesn't actually mean that much is happening in this space. And I'm involved in a few global groups that are involved in the discussion. And in some of the groups, we're at least compiling the information so that you can make better sense of what the research points to. And in fact, PricewaterhouseCoopers presented this analysis of 59 ethical AI principle documents to say, if we look across all of them, what are the shared topics? What are we really interested in? Now, because my focus is on robotics, which these days is being considered a subset of AI, it worries me a little bit that safety is so low down because there are many documents talking about the principles of AI that do not include robotics at all. Whereas once you start to talk about a physical system, something that's embodying AI, then safety becomes your primary concern. To the extent that it worries me that we focus on safety and we don't look at things like transparency, accountability, fairness, diversity and inclusion, or interpretability and explainability. If you're interested in looking further, there are new laws of robotics, and I have them on my website. I have adapted them from the EPSRC principles of robotics, which is the UK group that includes Alan Winfield and Joanna Bryson. I'll share a link with that after, because I've leapt over what the laws of robotics are, because we don't have a lot of time left for this talk. And one of the things that I'm very interested in doing that many of the groups are not, is saying, what are things that we can do? What are things that we can all be involved in doing right now? And I think one of the most obvious things is to say we need a robot registry. This is what the FAA in the US has done with drones once they're greater than a certain small size. So for the little $20 drones that you buy at the mall, or used to buy last year at the mall, that buzz around your living room and bounce off your head without doing any significant damage, those are toys and they're not considered. But once you get a little bit larger, these become toys that can do damage. And at that level, there should be some form of registry. But what I see at the moment is the rollout of a heck of a lot of robots for logistics, robot delivery, for food delivery, not just drones, but on the street delivery. A lot of these companies are avoiding the self-driving car paradigm. They're doing small-scale vehicles or sidewalk traveling vehicles where there are no actual requirements for them to be registered. although we're seeing a lot of cities start to introduce some sort of requirement once they realize that their sidewalks are becoming cluttered with electric scooters and delivery robots. But to go one step beyond that, it would be wonderful to be able to identify a robot. I think all robots that are larger than a tiny toy should come with an identification. And then it should be possible to look that up so that it becomes transparent, so that we know who is accountable for that robot. Another step along the transparency vector is the recent model cards that had come out of the Google AI ethics group with Margaret Mitchell, Timnit Gebru, a number of others, and introducing a form of standardized benchmarking for algorithmic transparency. And I think you can find that on a Google website if you search for model cards for transparency. And that would go well with a robot registry. This would become part of the registration process. Now, there is another thing that is being put into place in the biotechnology industry, and that's independent ethical review. So that didn't really exist in the 50s and 60s. And some quite nasty experiments on people were being done, which is why the independent ethical reviews came about as an important part of developing technologies that were not going to be totally unethical, or that were going to provide some protection for groups of society. If you want to look at this further, then look at things like the Tuskegee syphilis experiments, where Black people, go and look at that. Or Henrietta Lacks, The Immortal Life of Henrietta Lacks is a fantastic book. But you'll see that in America, Black people were used as experimental animals, effectively. And the Independent Ethical Review Board has been proven to be one way of reducing these sorts of issues. And if you look at Joy Buolamwini's recent documentary film Coded Bias, then one of the points that's being made is that the Black community is where experiments on AI technologies are taking place. For example, surveillance technologies and facial recognition are being rolled out in poor neighborhoods, not in rich neighborhoods. And in fact, if you look at the number of neighborhoods that have voted against using facial recognition technologies, you will find that they are affluent cities and neighborhoods that have taken those steps. Step 4, this is another thing that I think we can do to develop better technology in the interests of society, and that's to create ombuds people. This is an idea that dates all the way back to the Greek and Romans. An ombuds person is a representative of groups that don't otherwise have voices. And I think the most important thing we can be doing is to be looking at the transition of information from underrepresented groups of society into the development of our technologies. Finally, and Silicon Valley Robotics started the first Good Robot Industry Awards in 2020. Rather than the stick, we are favoring the carrot approach and saying, well, let's promote companies that are doing good with their robots. And the concluding points are, we need everyone to get used to working with robots because there are simply not enough people to build the number of robots that we actually need to improve productivity and to solve our global challenges. We need people to transition into robotics, including the computer science aspect of it, which is where the majority of the robotics jobs are. And we need everybody to feel empowered in understanding what is happening with robotics and AI and having a role to play in it. Generally speaking, I think there will be 10 new people jobs created for every robot that is deployed. So I'm very optimistic about our robotopia future. And my final message is just don't fall for the bullshit. Robotics is one of the most multidisciplinary fields out there, but I don't see many lawyers, many economists, many policymakers, or people in the social sciences. And my background was human-robot interaction. And that tends to be limited to the psychological aspects or the user interface design aspects of operating robots, rather than the broader social implications of technology. So people in the robotics field are not necessarily well informed about any of the other fields around the impact of their technology in society. And computer science might seem like it is, how do we say, it might seem as though it is objective and clear, but we haven't yet created common sense in terms of operating in the real world. So question what you build, why you build it, and question the perceived wisdom from many of these people who might be experts in computer science, but might not have any real expertise in the rest of the world. And thank you very much. I think we're going to have some time for questions. So please reach out to me and please share your questions in the chat.
I'm out of words. I'm like, wow, thank you, Andra. You covered a variety of issues within robotics, and it was really interesting and informative talk. So, like Andra said, we'll be taking our Q&A session. So I'm looking at it right now. We have one question. So someone asked, as someone who is interested in problems in AI, how can I further pursue this interest without my work causing these issues to worsen, and like possibly work towards combating modern issues of capitalism?
Exactly. Well, I'm quite hopeful. In fact, I was quite inspired by a paper from Michael Jordan at Berkeley, where he talked about developing an intelligent infrastructure with AI. And it's really these non-obvious use cases. I mean, if AI is the new electricity, it's a form of infrastructure. And if we think about the arguments about providing free and open access to the internet, and then we expand on that, think about, can we provide free and open access to artificial intelligence, computational resource, or data sets, or the way we work with these things? And can we use the tools that we're developing to improve, to relook at some of these social issues that have been intractable? So generally speaking, social issues are intractable from a computational standpoint. But as we're achieving more power, it is possible that maybe we can pick the right problem and frame it carefully. For example, I did see people using AI to redistribute voting districts, or to develop maps that would showcase the results of different redistribution for electoral districts. And then, of course, the human question is, which one is fairest? And I think we're going to hit these complex situations over and over again. But I believe that we can start to look at, I guess, categorizing and cataloging the results of which ones are fairer by which vector or which metric things are fairer. and then have a more informed discussion about things. Okay, so the trolley problem gets used all the time, and it's ridiculous. It's a philosophical argument tool. If you don't know the trolley problem, it's the one that says, if a self-driving vehicle is traveling towards hitting an old person, should it? And the choice is to change path and hit a young person. Which one should be killed? I'm like, that's ridiculous, because the choice should be not killing anybody. And indeed, that's how the technologies, that's how people would attempt to be designing it. It's a ridiculous, it's a thought problem rather than a real problem. But if you look at what is the reality in developing self-driving vehicles for real deployments, which is still a long way off, a lot further than people were talking about, then there can be a lot of safety benchmark testing. And we incrementally have much, much smarter cars today than we had even 10 years ago, because things that were tested over and over again that are proven to be more effective than human. For example, our ABS, our automated braking systems. There have been many things that have made their way into our technology that perform better than human through testing. And it hasn't replaced humans as the driver. So that final step to having full autonomy is still a very long way away. But there are things that we can do where we can look at it and test it and say, but is this a better result? So it's a lot of really cumulative small changes in some aspects. And I think that if we start applying AI to many of these things, and we've seen it with, say, diagnostics, but don't believe the Kool-Aid that because we're getting better diagnostics from using AI, that we're going to replace doctors or pathologists or, you know, insert profession, because there is no indication that we're heading towards any more broadly contextually intelligent system at all. Yes, the ethics backlash and the new workers' union. I would like to see all technology workers unionized. We've kind of kneecapped the whole union movement, and I'm hoping that bringing it back will make a difference. There are a lot of things that I wonder if we were motivated by solving problems for large numbers of people. Can we not use the same technologies that allowed Amazon to take over so many stores, because e-commerce became simpler and offered greater benefits than going to a brick and mortar store? I'm just as guilty of hitting click to purchase things. I love it. But I say, are there ways that we can allow people to develop unions, for example, or perhaps to develop data markets that would allow us to all share in the potential money that is made in the aggregation of data? And so one of the deep economic flaws right now is the fact that it isn't our individual data that is valuable. It is the product of the algorithms on a large data set that is valuable. And so therefore the value captured is going to the companies that control the algorithms. Can we just change the way that we structure these things? So I love that you pointed out this. I do think that there is no motivation for companies to change for the better. So I believe that our motivation has to be to develop new companies that have a different set of shareholders or stakeholders. And so that's a little bit of the discussion around stakeholder capitalism. And where do I see AI and robotics in 10 years from now in terms of space and development? Well, I call this moment Robotics 2.0. And Dr. Gil Pratt, was at DARPA and is now at Toyota, talked about this being a Cambrian explosion in robotics. And just like the biological Cambrian explosion, it is the incorporation of navigation, of vision. It's the incorporation of primarily vision, but sensor data that allows an autonomous system to understand where it is in the world and how to move. Now, that is a very, very long way away from any human level intelligence, but that one step forward in intelligence is rippling out through every aspect of robotics. And so we're going to see robotics that is going to be able to be in every industry, from space all the way towards social interaction. That one is not going to be great, but it's led to, for example, if you look at the simple robot vacuum cleaner, we've gone from the Rodney Brooks style robot vacuum cleaner that bounces off walls but covers the floor, to vacuum cleaners that are using sensors, that are remembering where they've traveled, that are planning where they're going to travel next. So this is the Robotics 2.0, and it's just the tip of the iceberg right now in terms of the areas that will go. I think we're going to spend most of the next 20 years simply deploying slightly smarter robots that are capable of navigation in so many different areas of the world, of our industries. And that's going to be enough to give us a huge productivity increase. That's what I'm hoping is going to be the way we deal with the aging population, demographic issues, and all of the other social problems that is coming up. For example, doubling world food production by 2050 without destroying any more land. So right now, we've used all of the arable land. How do we double our food production? So I look at these global challenges and I say, how do we build good robots? We solve global challenges. And simply that ability to navigate in real time is going to allow both precision and unique deployment. I don't think we're going to see another significant change in terms of the real intelligence of robotics. Elon Musk is a very inspiring showman. I'm not aware that he has any experience in directly in robotics, or indeed in any of the social sciences. It's a little bit like, although let's look at Bill Gates as slightly on the other end of the spectrum. He talks about robots and he says we need a robot tax. I'm kind of like, firstly, do you understand robotics? Secondly, do you understand economics? And I will give him credit for saying I believe he's done his homework. Whereas I think Elon Musk is surfing a particular wave and he's inspiring people, which is fantastic. He's accomplished a huge amount by looking at these things as, if this happens, if we want to get to here, then we're going to need this to happen and this to happen. And he's simplified problems and focused on that. I wouldn't expect him to have broader thoughts beyond his laneway. I'm not certain about the directions that the AI ethics groups that are heading in, or indeed the brain reading groups. There's a lot of, it's a little bit like when drone delivery started. I lost track of the number of times I saw a headline saying world's first drone delivery or world's first commercial drone delivery. It happened over and over and over again. And yet we didn't really have any significant commercial industries that had started. We're still waiting for commercially successful drone delivery. Yet we've had 10 years of headlines. So Elon Musk does a lot of headlines. And this was one of the points that Oren Etzioni made right at the start around the canary in the coal mine. If you look up that article, he's talking about how super intelligence, I think he says, solving the problem of superhuman intelligence is a little bit like worrying about overpopulation on Mars. There's a lot that has to happen before that is an issue. We waste a lot of time discussing it. Okay. Yes, climate change, I think, is simulation is starting to be a really important tool in the academic toolbox and beyond. And the fact that we're starting to be able to look at more complex scenarios, the problem is it turns out that our ability to work with complexity is just scratching the surface. One of the things that I found terribly inspiring was that the modeling of the COVID virus, not AlphaFold, but before that, some of the initial modeling was done on a citizen science network of connected computers that created one of the world's largest supercomputers. So in robotics, I see the role of simulation all the time. If you look at the DARPA Sub-T challenge, it occurred entirely in simulation recently because of COVID. But before that, we've seen it in the DARPA Robotics challenges that many teams are able to compete purely on simulation at the first stage. And that makes it far more economic. And if you can prove what you can do in simulation up to a point, then you're a much better bet for investing in real expensive robotics technology. And anybody who works in robotics knows that robotics usually don't work. The first thing that I was introduced to was the roboticist saying that, what's the definition of a robot? It's something that doesn't work in a demo, because once it works reliably, repeatably, then it's a product. And so really robotics is a moving definition of the things that we're still trying to work out and get right. And so that's why the definition has shifted so much in the last 50 years. And it's what's so interesting about the field. We really have hit a paradigm shift in the Kuhnian sense. Robotics today is very different. We're now able to use many of the algorithms that were developed back in the 60s and 70s that simply couldn't be useful in real time. And this is the things that are allowing us to navigate in the world, to make responsive choices in navigating in the world. I'm getting carried away here. If there are other questions.
No, this is great. I have a question myself. You talked a little bit about diversity in tech at the beginning and gave a couple of examples in your presentation about certain technologies being used against minority groups. And I wanted to ask, like, do you think it's like a lot of these issues are not just like in robotics, but in tech in general? Do you think with the rise of diversity in tech, hopefully, do you think these issues would go away, or will we have a whole nother set of issues to deal with? What are your thoughts on that?
Sadly, I think we're developing a whole nother set of issues because the diversity in tech numbers are not rising fast enough. Effectively, we have whistleblowers or canaries who are members of underrepresented groups. And as we see with whistleblowers like Timnit Gebru, not rewarded. So I'm hoping that we're going to continue to both see people speaking out and start to protect them, or, you know, respond more positively. I just came from a discussion about this very thing, and let's say the women in the room said, I think we're just going to have to start from scratch because we're not going to be able to turn the tide in these organizations that are already massive and have already taken on a culture and developed in a certain way. And in fact, this is a concept called the diversity debt, which has come out from Project Include. And don't believe that diversity is incrementally getting better. If you've studied sociology, then you know that there is a kind of a step, a paradigmatic step at around 25 to 30%, where suddenly a group goes from being an acceptable diversity level to being seen as socially threatening. And if we look at politics at the moment, we would argue that in the US, there is a real clash of cultures. Because if you listen to the white voices, they're outspoken in believing that they're just responding to the provocation from the left and the black communities. Whereas if you listen to the voices from the left and the black communities, then they're saying, we don't get treated the same, we get treated very differently, and we get very little benefit and no benefit of the doubt. And there are completely opposing viewpoints. And in anthropological, sociological terms, it's like a subgroup is allowed to exist up to a certain point, and way less than 50-50, suddenly it becomes seen as dominating. And the human history is, at that point, the dominant group gets kind of stroppy and says, "Nah, back in your box." So I would say that there's a lot of evidence in history that we need to start new things that are starting better, rather than trying to fix things that are already pretty broken. And
Wow.
yeah, that's the
Thank you.
But I believe we now have a lot of people that
Yeah.
are interested in doing so. And I'm just kind of like, don't necessarily waste your efforts on trying to solve old problems. Put your efforts into creating better new things. And that's why I do believe that robotics is an answer, because robotics is still terribly new as a technology, and it is a high impact technology for all of our computer science. And there are so many things that we can do to make the world a better place using it. So, let's leave it on that positive note, and let's keep working on making the world a better place.
Thank you so much for being one of the speakers at CUSEC. I think that really sums everything up. And now the next event is social, so I guess I'll wrap this up with another thank you. But yeah, if you guys have any questions for Andra, you can ask in the Discord channel if you have the VIP ticket. Again, thank you so much.
Great. I will